The flamethrower was one of the most terrifying weapons introduced throughout World War I. The weapon proved to be an excellent instrument against fortifications and trenches, blasting the enemy with scorching liquid and flushing out the apparently impenetrable opponents. Even with that, it wasn't enough. The flamethrower was not enough. It was effective, but at the same time, it was not. And so later on, it was abandoned for other projects after World War I, until they formally discovered napalm.
You know, the wind's blowing real bad and you can't. Spark on your flint and steel, or you can't get your fire to light at all. Then, you know, put this underneath it, light it, and it'll catch and it'll stay. To go, and then
Before, liquid fuel was used for flamethrowers, but the use of the sticky fuel thickeners, napalm, was found to have increased the lethality of flamethrowers. With new designs for the flamethrowers, the thickeners nearly tripled the weapon's effective range. From a toxicological perspective, carbon dioxide levels can reach as high as 20% in the presence of burning napalm, with a level less than 10% being known to cause rapid deoxygenation, loss of consciousness, convulsions, and death. After it was invented, napalm was able to prove its usefulness when around 60 Japanese cities were napalm incinerated and around 100,000 people killed in only the Tokyo raid in World War II. So now, what is napalm? What makes napalm such an effective incendiary? What makes it so special? Well, napalm is a chemical incendiary aimed to cause fires, which is produced by combining a gelling powder mixture of naphthalene and palmitate with gasoline in various quantities to make a sticky, burning substance, resulting in intense burning at temperatures up to 1,200 degrees Celsius. It was made to tenaciously stick to targets and made to last on surfaces of buildings, furniture, and skin. And although the video of the homemade napalm shown above isn't exactly the same napalm used in World War II, it was still used in other battles like the Vietnam War and is simply the modern and safer napalm called Napalm B. Napalm B can easily be recreated with merely 3 very accessible components, one being the gasoline fuel you use for cars, 2, benzene, the highly toxic chemicals found in glues or tobacco smoke, and 3, some random styrofoam you can probably find in your kitchen. To explain it in chemistry terms, gasoline is fuel that's highly combustible because of its low flash point, which means a minimum temperature at which its vapor will ignite if given an ignition source, and also because of its high vapor density, meaning a ratio of density of vapor to the density of air. So substances with a vapor density greater than 1 are heavier than air and tend to accumulate in low and enclosed spaces. Polystyrene is a thickening agent, and a thickening agent, or a thickener, is a substance which increases the viscosity of a liquid without substantially changing its other properties. Polystyrene is used to slow the reaction, making the fire last longer, and to cause it to be sticky. An example of polystyrene is styrofoam. Benzene is also combustible, but burns at a slower pace compared to gasoline. When you mix it together, polystyrene will dissolve in gasoline, like cotton candy dissolving in water. Then you add benzene, and after the mixing, you will be left with a sticky, slimy mixture, and that mixture is then called Napalm B. Fuel gel. If you still have a hard time understanding what napalm is and how it's effective, here's the takeaway. 1. Napalm is a fuel gel mixture with stickiness and extreme high burning properties, whereas napalm is merely a simplified version of it. 2. Napalm B can burn and cause great effect because of its components, which are gasoline, polystyrene, and benzene. And now, since you know that daily life things can be dangerous and harmful, here's the last takeaway. Don't go around making random stuff without knowing what you're actually doing. So be careful, because you might actually and accidentally make a bomb.